So are you able to see my PPT screen?
Yes.
Yes.
Okay.
Yes.
So yeah, myself Chaitra, and I'll be walking you through the SQL from fundamentals to hands-on practice with the real-world examples. So yeah, so let's go start with the introduction. So what is PostgreSQL? It's an open source object relational database system known for its reliability, stability, and advanced features. So object in the sense, we can use object classes, inheritance, encapsulation, and methods like other programming languages like Java, C Sharp, Python. And relational database because it stores the database in tables with rows and columns. It also supports SQL, foreign keys, joins, constraints, and relationship. Hence, it's an object relational database system. So key features are it's an open source, free to use, and backed by a strong community. ACID compliant. So ACID stands for atomicity, consistency, isolation, and durability. It ensures reliable transactions. Supports structured and semi-structured data. Extensible. You can define your own data types, functions, and operators. And high performance with indexing, query optimization, and concurrency control. So where is PostgreSQL used? It's used in web applications, data warehousing, and analytics in geographic information systems. So while on PostgreSQL, it has industry standard SQL syntax, it has a strong community and documentation, and it's widely used by top companies. So a fun fact, PostgreSQL's mascot is an elephant. You have seen the elephant image. It represents its ability to handle large and heavy data loads. So few terminologies here. So PostgreSQL Server. So it's a software that runs on the machine and it can host multiple databases. What is a database? It's an isolated unit inside the PostgreSQL server. Each database can have its own set of tables, indexes, functions, and users. So it's a structured collection of data that is stored and managed by the PostgreSQL database server. So you can think of it like a container where all your tables, schemas, functions, views, indexes, and other database objects live. Next, schema. So inside a database, schemas help organize objects like folders. So the default is usually public. If you don't specify the schema, it creates all the tables under public schema. So you can see in the image here, there is a PostgreSQL server. Under that, you have database 1 and database 2. So in database 1, there is a schema A and schema B. And under that schema, you can find the tables. So if you don't specify the schema, there will be a public schema. Inside that, tables will be created. So you can imagine like this with a real-time scenario. So if your PostgreSQL server is like a library building, then each database is a separate book collection in that building. And schemas are like sections or shelves inside that collection. Okay. Now, how do we connect to the database? So to connect to the PostgreSQL database server, there are two ways. One is pSQL and pgadmin. pSQL is a terminal-based utility to connect to the PostgreSQL server. It's an interactive terminal program provided by PostgreSQL. pgadmin is a web-based tool to connect to the PostgreSQL server. So it allows you to interact with the PostgreSQL database server via user interface. So let's see how do we connect to the pSQL shell. So here you can see my screen, right? The SQL shell. So you have server, local host. So my server, I'm running in my local machine. So it's by default, it's saying local host. So I'm not connected to any other server. So I'll just leave it default. So I'll just type enter. And the database by default, it's Postgres. It's a system defined database. So by default, it's showing Postgres. So I will change it to like user defined. So I have a database called Northwind. So I'll just give like Northwind. And port by default, it's 5432. I'll not change it. I'll just type enter. Username also, it's by default Postgres. So I'll not give anything. So password, I'll just type my password. So I have typed, it will not show the password. So I'll type, and now you can see it's the Northwind. It's connected to Northwind database, and you can run your queries here. Okay, this is through the terminal. Now let's see how we connect through the UI. So this is the pgadmin I have already opened. So you can see here the databases. Under this, you can see many databases. So I have created like all these databases. So you can see Postgres. This is a system defined database. It will be installed by default. When you are installing PostgreSQL, this will be like installed by default, this database, and all the rest are like user defined databases. So let's see how to create and alter a database. So PostgreSQL Server database can be created, altered, and dropped graphically using pgadmin or using a query. So let's see how we create here. So I can just come here, database, and I can just give create database and just give some name. Okay, so you can see here, Chaitra, the database is created. You can create like this, or we have query also. So I'll just delete this database for now. I don't want it. Okay, so it's deleted. Let's see how to create a database using the query. It's taking a long time today. Okay. Okay, so let's see how to create a database. So create database is a keyword followed by the name of the database. Okay, so create database sample. I'll just execute. So you can come here and execute. Okay, so you can see query returned successfully. You can come here and see. So you can see here the database created sample. And if you see it's all lowercase. So here, I gave like capital letter S, but if you see it converted everything to lowercase. So database and table names are case insensitive, and PostgreSQL will automatically convert the database name to lowercase, and unless you wrap the name in the double quotes when creating it. Okay, so if you want a database like with the S capital, then we have to like enclose it in a double quote. So I'll just execute this one query now. Okay, so let's see here. So if you see, so there's one more table here at the first table database sample. So S is capital. So you have to enclose in the double quotes. So next is to alter the database. How can we alter the database? We have a command, alter database. So alter database is a keyword followed by the old database name. So I want to rename the previously generated database sample, rename to, even that's a keyword, followed by the new name. Okay, so sample 2 is the name I'm giving. So I'll rename it. Let's run this query. Okay, there is one more database. Yeah, sometimes you get this error. You have to like either close everything and open it. So let's try once. I'll just close this, or you have to kill the connection manually. I'm renaming this. I'll go here. So let's try it. Sometimes you get the error again, and yeah, sometimes you get this error. So let's try to kill the connection. If that doesn't work, then we have to restart and see. I'll just write a query to check if I have any connections. Okay, there is one here. So if you see sample, so I have to kill this connection and then let me try again. Okay. So I'll give 3, 7. Yeah, I'll just try to. Okay, so let's see if there is any connection now. So let's try now sample. Okay. Let's try now running this command. Okay, so I have renamed it to, there should be one called sample 2. Okay. Okay, so alter, and then how to delete or drop a database. So we have a command called drop database. So drop database followed by the database. So I just want to delete this sample 2 database. Okay. So I have sample. I'll be using this for training today. Okay. So let's see the data types. So these are the common data types we use in the project. So we have integer, we have numeric. Numeric is for like decimal or floating point. So you can also use decimal and float data type. And for character, we can use char and varchar. So char is for fixed length string. When you know the exact length, we can use char. Varchar is for variable length string like name, email. So you don't know the exact length, and you can specify the maximum limit like n. So you can specify like 50 characters, 100 characters. So if you don't specify, it will have like some default limit. And text is for unlimited length. And boolean for true false values, and date time for date time with and without time zone. So these are the common data types we use. There are other data types as well, like binary, monetary for money, and geometric data type for storing two-dimensional geometric data. They are used in like computer graphics and geometric modeling. So how to create the tables inside a database? So this is the syntax. So tables allow you to store the structured data, like it can be like customers, products, employees, students, anything. And so you can see here, if not exist option. So this is optional. So when you use this if not exists option, it will create a new table only if it does not exist. And if a table exists, then PostgreSQL will issue a notice, but it will not give you an error. So, but if you're not using the if not exist keyword, then if there is a table and if you are trying to create a table with the same name, then it will throw a error. Okay. So let's see how to create a table. So I'll just create a table in my sample database. Okay. And it's connected to sample. So you can see here. So I'm creating a table. Create table is the keyword with the table name. So accounts is the table name. And I'll have a all these are the column names. So user ID, username, password, email, created at last login. All these are column names. So serial, I will like explain it shortly, and primary key. Even this I'll explain shortly. So we have to define a primary key and we'll give a serial. We'll say it serial. So varchar is a data type. So we for every column name we have to tell the varchar. So username is a character. So I'm giving varchar, variable length string. Password also, email varchar, created at it's the time. So I'm giving timestamp. Even last login will have the time information. So I'll just put timestamp. So it will have both the date and time. And all these are constraints which will be explained shortly. So unique, not null. Okay. So but this is how we create a table. So there should be a create table and create table name, open bracket, and column name followed by the data type and any constraints, primary key, unique, not null. So you have to mention the constraints. So let's run this. So under schema, you will find all the tables. Under the database sample, you have schemas. So it will be in public schema. Schemas, and under public, you will find the databases. So accounts. So you can see the table here. And you can see the columns. and the constraints here, if any. So I have like primary key, unique constraint, so that will be displayed here. Okay, so primary key and unique constraints. So inserting the values to the table. So how do we insert? This is syntax. Insert into, give the table name, give the column names, column 1, column 2, values, and the values should be like in the order you specify the column name. Okay. So insert into, give the table name accounts, give the, so when we say user ID serial, I need not specify that here in the value in the column name. Okay, it will auto generate. So we'll explain that, we'll look into it shortly, but when we give serial, it's like it will auto generate the values. So I'll not give that column name here. So from username, I'll start username. I have password, email created at last login, values. So I'll give the name, so username, password, email, and so created it and last login timestamps. Okay, and we can like insert multiple values in a single shot. So we can just separate it by a comma and give one more value. Okay, so let's run this. So we can see the values. We have the select. So when we do select, it will show it will show the table and all the values. So it should show two values. So you can see here username John and Alice have been created here with the values we gave. And if you see user ID, it's auto generated 1, 2 because I gave serial. Okay, so it will auto generate. So let's see, look into serial sequence identity we used just now. So the sequence is a special kind of database object that generates a sequence of integers. And this sequence, it's often used as primary key column in the table. If you see in the last example, when we created the accounts table, we used that as a primary key column. Okay. So when creating a new table, automatic number generation can be handled in three ways. So using serial, sequence, or identity columns. So first is serial. It creates a sequence automatically. Sequence, it requires manual creation and control. Identity, it's a SQL standard. It handles auto increment and control. So let's see one by one. So let's start with the serial. So I'll just create one more table just for your reference so that you can like understand clearly. So I'll just take a create table fruits and I have ID, serial, primary key and name. Okay. Okay. So the table is created. I'll insert one value Okay, so I'll not pass because the serial will automatically generate the numbers. So I'll not pass ID. I'll just give name and the value for the name. So what you should see in the output. So yeah, ID 1 and orange. So if I try to give the value, so it should not take it. Okay, so if I give like 2 comma something value, so it should throw me a error. It will not allow me to give a default value. So it will automatically generate the numbers. So it will not allow us to give the pass the value. Okay. So that's about the serial and sequence. So even this is used to generate a unique identifier for a primary key in the table. And we can also use sequence to generate unique numbers across the tables. So if we want the numbers to be shared between two tables, so that when we use sequence most of the times, and we can control from what number the sequence has to start and the incremental value. But we have to manually create a sequence. In serial, we didn't create manually anything. We just specified like ID is serial. But here we have to manually create a sequence and we have control like from what number to start and the incremental value. Let's see that. So I'll create two tables. So I want the ID to be shared across two tables. So I'm creating a table sales underscore invoices and I have two columns, invoice ID and customer name. So I'll create one more table, purchase invoice, and same I'll have invoice ID, serial, primary key, and supplier name. So now I have to create a sequence manually here. So this is a sequence. So create sequence and give a name for that. And starting from 1, I want to like increment. You can give like 2, then it will start from 1. If I give increment 2, then 1, 3, 5. That will be the order. So if I give increment 1, so I'll create a sequence now. Then we'll use it while inserting into the tables. Okay, so I'll insert into sales invoice table. So insert into sales, give the table name and the column names and the values. So if you see here, I'll give next value. Okay, so I have to like manually specify here next value. So it will like start from 1 and it will give the name here, customer name. And I'll also insert into the purchase invoice. So let's see what is in the sales invoice. So it should be 1 because starting from 1 and ABC Corp is the name. So I should have one record. Okay, now I want one record in the purchase invoice, and the invoice ID should be 2. Okay, so it should be shared. So it started from 1 in the table sales underscore invoice. I want this ID to be incremented when we are using one more in this purchase invoice table.
Chaitra, every time you can just execute the script instead of executing the query.
Yeah, I
That's why
think it
it's
will
taking
execute the
so
whole
much of.
thing. So I don't want that to happen.
No. When you select and execute, it will execute
Okay.
only whatever you have selected. But since you're executing it through query, it is taking so much
Yeah.
of time every time, right? So you
Okay,
can
let me
just,
try that. Yeah.
yeah.
And also, Chaitra, sorry for the interruption. Could you please increase the screen size? It's very hard to see.
Is it small?
Yeah, for me, I'm not sure about others.
What
The
she said,
letter size is font size is small.
Yeah, we can increase the size on even the Zoom
actually,
call.
we all can do it ourselves when we just.
I tried on
Actually,
my
can I
end.
zoom in? I don't know if it works. Okay, can you see
Yeah.
now?
Yep.
So is
Yeah,
it
it's
enough?
better. Yeah, it's better now. Thank you.
Okay, so I'll just check what is there here. So it should be 2. So the sequence, it is shared across the table. Okay, so I'm using this next value. So it will start from 1, and whenever I insert, it will take the next value. So it started from 1. Next time I'm using it in a different table, and it will increment for that. Okay. So these two are like were there in the older versions. So identity is something new. So it's I think it was introduced from PostgreSQL version 10. So it also allows you to automatically assign a unique number to the column, and you have control from what number the sequence has to start and the incremental values. So let's just look into that as well. How do we create it? So I'll just create a table called color with the color ID and color name. And here I'm not giving serial. So I'm giving int and generated always as identity. Okay, so this is for if you want the identity column, if you want the color ID to be the identity column, then we have to use generated always as identity. So again, same, just try to insert one value, and so it will start from 1. And even here, if you try to give like pass a value, then it will throw error for the ID column. If I give like 2 comma red or 3 comma red, it will give error. So okay, so it will automatically generate the number for the color ID. So I'll just drop this table and I'll just recreate it with one more option we have for the identity column. So if you want to specify the ID value, color ID, then we have one more option. So let's do that. So I'll just create one more table and I'm giving generated by default as identity. Okay, so here we can specify the color ID as well. So I'll try inserting. So I can also pass the value for color ID here. So it will not throw an error. Okay, so one white and it took the value to yellow. So if you want to give, so when to use like which one to select among these, so you can. So if you are building only for PostgreSQL and want something quick, like for the training purpose, then you can use C logic between two. Then you can use sequence. And if you're working on new projects and you want you care about the SQL standard and portability, then go with the identity, or it may be a different server. Then in that case, we can use identity column. So next, coming to the primary key and for
Sorry, what did you say? You can use the identity column for again?
like if you care about the SQL standards and portability, like if you're using PostgreSQL today and tomorrow there is a chance like your project may be using a different like MySQL server or any other servers, then in that case like we can go with the identity.
Okay.